about the aldehydes, ketones, and carboxylic acids in the chapter, which is consisting of 32 pages. I'm not sure that whether we'll be able to cover it in this day, but let's try it. Try it as hard as possible. So aldehydes, ketones, and carboxylic acids. So basically, these are carbonyl compounds. Carbonyl compounds are of utmost importance to organic chemistry. They are the constituents of the fabrics, flavorings, plastics, and drugs. ஸோ மோஸ்ட் ஆஃப் த ஆர்கானிக் காம்பவுண்ட்ஸோடைய அந்த முக்கியமான பங்களிப்புன்றது இந்த கார்பனல் காம்பவுண்ட்ஸ், அதாவது இந்த கார்பன் மற்றும் ஆக்சிஜன் பாண்டடான காம்பவுண்ட்ஸ்லேருந்து தான் வருது. ஸோ இது எல்லாமே வந்து ஆர் த கான்ஸ்டிடியூவன்ஸ் ஆஃப் ஃபேப்ரிக்ஸ், ஃப்ளேவரிங்ஸ், பிளாஸ்டிக்ஸ் அண்ட் ட்ரக்ஸ் அப்படின்னு சொல்லியிருக்காங்க. ஓகே, so next after studying this unit you will be able to write the common and IUPAC names of aldehydes, ketones, and carboxylic acids. Write the structures of the compounds containing functional groups, namely carbonyl and carboxyl groups. Describe the important methods of preparation and reactions of these class of compounds. Correlate physical properties and chemical reactions of aldehydes, ketones, and carboxylic acids with their structures. Explain the mechanism of a few selected reactions of aldehydes and ketones. And we will be able to understand the various factors affecting the acidity of the reactions and describe the uses of aldehydes, ketones, and carboxylic acids. We'll see how to write the common and IUPAC names, the structures, and then we describe the preparation methods and the physical properties, and then chemical properties. Chemical properties implies reactions with a certain other type of compounds, and then finally we will enter into their uses. That's all we'll do, and that's the sequence we'll follow for every other organic chemistry chapters. So this is the 8th chapter. So in the previous unit you have studied organic compounds with functional groups containing carbon, oxygen, single bond. In this unit we will study about the organic compounds containing carbon, oxygen, double bond called carbonyl group. So that is the C double bond group, which is one of the most important functional groups in organic chemistry. So carbonyl group is attributed to be the one of the most important functional groups. Moving on, in aldehydes, the carbonyl group is bonded to a carbon and a hydrogen. ஸோ ஆல்டிஹைட்ஸ் அப்படின்ற இந்த டைப் ஆஃப் காம்பவுண்டில் வந்து ஒரு கார்பனல் குரூப்ன்றது பேசிக்கலி இட் இஸ் பாண்டட் டு ஒரு கார்பன் அண்ட் ஒரு ஹைட்ரோஜன். whereas in a ketone it is bonded to two carbon atoms. So basically if a carbonyl group is bonded to two carbon atoms it's going to be a ketone, and if it is bonded to a carbon and hydrogen it's going to be an aldehyde. The carbonyl compounds in which a carbon of a carbonyl group is bonded to carbon or hydrogen and oxygen of hydroxyl moiety are known as carboxylic acid. அதாவது இந்த கார்பனில் காம்பவுண்ட்லேயே இந்த காம்பவுண்ட் இந்த ஹைட்ராக்சில் மொய்டி அப்படின்ற இந்த பர்டிகுலர் குரூப் அண்ட் இன்னொரு சைடில் வந்து கார்பன் குரூப்போட ஆட் ஆகியிருக்கிற இந்த பர்டிகுலர் டைப் ஆஃப் காம்பவுண்ட்ஸை வந்து நம்ம கார்பாக்சிலிக் ஆசிட்ஸ் அப்படின்னு சொல்லுவோம். where in compounds where carbon is attached to carbon or hydrogen and nitrogen of the amine moiety or to halogens are called amides and acyl halides respectively. So basically if it is bonded to a NH2 type of group, so இங்கே பார்த்தீங்க அப்படின்னா carbonyl compound group which is bonded to a carbon or hydrogen, so it can be either a carbon or a hydrogen, and on the other side we have an NH2 group, it's called an amide because an amide is a type of amino functional group compound which is bonded with a sp2 carbon. And similarly we have acyl halide where one of the one of the atoms bonded with the carbonyl compound is going to be a halogen. So that's the important part. So அதுதான் acyl halide அப்படின்னு சொல்லுவோம். So esters and anhydrates are derivatives of carboxylic acids. The general formulas of these classes of compounds are given below. ஸோ எஸ்டர்ஸ் மற்றும் ஆன்ஹைட்ரேட்ஸ் இது இரண்டுமே வந்து இந்த பர்டிகுலர் கார்பாக்சிலிக் ஆசிட் குரூப்ஸோட ஒரு டெரிவேட்டிவ்ஸாக கருதப்படுகிறது அப்படின்ற சொல்கிறாங்க. ஸோ ஆஸ் வி கேன் சி in a carboxylic acid group we will have a hydrogen in this place and we are having a alkyl group over here, and there is an acid anhydrate which means that RC double bond O, OC double bond O, R dash. That's what acid anhydrate is. Aldehydes, ketones, and carboxylic acids are widespread in plants and animal kingdom. So they add fragrance and flavor to nature. For so in the aldehydes, ketone, காம்பவுண்ட்ஸ் அனைத்துமே வந்து பிளான்ட் மற்றும் அனிமல் கிங்டமில் இருக்கிற ஒரு டைப் ஆஃப் ஒரு முக்கியமான மேஜர் ப்ரொபோர்ஷனில் இருக்கிற இது அனைத்துமே வந்து இந்த பயோகெமிக்கல் ப்ராசஸஸ் ஆஃப் லைஃப் சச் as digestion, அசிமுலேஷன், க்ரோத்து, ப்ரீத்திங்கு, இது எல்லாத்துக்குமே வந்து தேவைப்படுற ஒரு முக்கியமான டைப் ஆஃப் காம்பவுண்டாகவும் கருதப்படுகிறது. ஸோ தே ஆட் ஃப்ரேக்ரன்ஸ் அண்ட் ஃப்ளேவர் டு நேச்சர். ஸோ திஸ் இஸ் கோயிங் டு பி அ one important physical attribute. So they are adding fragrance. For example, we have vanillin. We will just use this type of color for marking certain important compound names such as vanillin. Vanillin is we obtain from vanilla beans, and we will have salicylaldehyde. Salicylaldehyde we are obtaining from meadowsweet, and cinnamaldehyde. Cinnamaldehyde we are obtaining from cinnamon. Have very pleasant fragrances. ஸோ இந்த மாதிரியான சர்டன் டைப் ஆஃப் காம்பவுண்ட்ஸ்க்கெலாம் வந்து வில் ஹாவ் ப்ளசன்ட் ஃப்ரேக்ரன்ஸ் அப்படின்னு சொல்லியிருக்காங்க. ஸோ ஆஸ் வி கேன் சி ஸ்ட்ரக்சர் ஆஃப் வெனிலின், இட் இஸ், அதாவது ஒரு பென்சீன் ரிங்கில் first we will have a aldehyde, CHO, obviously it's going to be aldehyde, and we are having methoxy group. So this is a methoxy group, aldehydic group, and we are having a hydroxyl group. ஸோ இந்த 3 டைப் ஆஃப் ஃபங்க்ஷன் குரூப்ஸும் இருக்க ஒரு பென்சீன் ரிங்கில். So if we are asked to draw the structure of vanillin, we will first benzene ring, and at the first position we will have CHO, and on the ortho, on the meta position we will have methoxy group, and then on the para position we will have a hydroxy group. So it's basically a phenol with ortho methoxy and para aldehydic groups. Salicylaldehyde, so salicylaldehyde basically it's a aldehyde, it's a phenol group. Phenol group la ortho position la we are having an aldehyde, adha salicylaldehyde. So this is salicylaldehyde. That's one important type of compound which gives the meadowsweet, I mean it is obtained from meadowsweet. So இதில் வந்து basically we are having a aldehydic and a hydroxyl group. So basically it's, we can say, a phenol group with a orthoaldehydic group, hydroxyl. Next we have CH double bond CH CH. So if I have in a benzene ring, if in a benzene ring, if in a benzene ring I have CH double bond CHO, and that's going to be something like okay fine, so it's CH double bond CHO, which means it's going to be cinnamaldehyde. So they are used in many food products and pharmaceuticals to add flavors. Some of these families are manufactured for use as solvents, that is acetone, and for preparing materials like adhesives, paints, resins, perfumes, plastics, fabrics. ஸோ இந்த சர்டன் டைப் ஆஃப் காம்பவுண்ட்ஸ் வந்து சால்வெண்ட்ஸாகவும் பயன்படுத்துவாங்க. அதாவது அசிட்டோன் அப்படின்றது ஒரு இம்பார்ட்டன்ட் கிளாஸ் ஆஃப் சால்வெண்ட்டுன்றதை சொல்கிறாங்க. அண்ட் இதை தவிர்த்து சில முக்கியமான கேசஸில் வில் யூஸ் இட் ஆஸ் அன் அதசிவ், பெயிண்ட், ரெசின், பெர்ஃப்யூம், பிளாஸ்டிக், ஃபேப்ரிக். ஸோ இந்த மாதிரி சில முக்கியமான கிளாஸஸ் ஆஃப் டே டு டே யூசேஜில் வந்து இது ஒரு முக்கியமான பங்கு வகிக்குது அப்படின்றத சொல்கிறாங்க. நெக்ஸ்ட்டு we'll enter to the nomenclature and structure of carbonyl group. So first, nomenclature for aldehyde and ketones. Aldehydes and ketones are the simplest and the most important carbonyl compounds, and there are two systems of nomenclature of aldehydes and ketones. One is the common name and another one is the IUPAC name. Common names: aldehydes and ketones are called by their common names instead of IUPAC names. The common names of the most aldehydes are derived from the common names of the corresponding carboxylic acids. ஸோ அதாவது மோஸ்ட் ஆஃப் த ஆல்டிஹைட்ஸோடைய காமன் நேம்ஸ் வந்து அந்த கார்பாக்சிலிக் ஆசிட் காமன் நேம்ஸ்லேருந்து டிரைவ் செய்யப்பட்டதாக இருக்கும் அப்படின்றத சொல்கிறாங்க. ஃபர்தர் வி கோ டவுன், வி வில் செக் வாட் இஸ் இட் பை ரீப்ளேசிங் த எண்டிங் ஐசி ஆஃப் த ஆசிட் வித் ஆல்டிஹைட். ஓகே, ஸோ அட் த சேம் டைம், ஸோ இது வந்து ஒரு முக்கியமான பாயிண்ட் என்னன்னா, the common names of most aldehydes are derived from the common names of the corresponding carboxylic acids by replacing the ending IC of the aldehyde with okay, the names reflect the Latin or Greek term for the original source of the acid or aldehyde. So என்ன சொல்ல வராங்க? Okay fine, it describes the Greek or Latin origin The location of the substituent in the carbon chain is indicated by the Greek letters alpha, beta, gamma, or del, etc. The alpha carbon being the one directly linked to the aldehyde group, the beta carbon the next, and so on, for example. Okay, fine. So, okay, so we are having these certain type of compounds over here. Great. So let's see certain examples. The first example being CH3 CH3C double bond OH is what we call as an acetic acid, which is a common name for, this is a common name known as acetic acid. I don't know the exact IUPAC name, but if we have to name an aldehyde derived from this, that is, we'll just replace the hydroxyl group with a hydride group. That means a H group, hydrogen, which means that it's going to be acid, and then we'll remove the ic acid with aldehyde, so it's going to be acetaldehyde. So that's how we name the aldehydes with a common name. And similarly, so this guy is a benzoic acid derivative. So this is benzoic acid. Benzoic acid is something like this. So we'll benzoic acid. I'm just replacing the hydroxyl group with the hydride group, so it's going to be a benz, and we'll replace the oic acid with the aldehyde, so it's a benzaldehyde. So that's how things are going to be. Next we are having beta bromobutyraldehyde. So basically, as you can see, the carboxylic acid group will be given the highest priority, so which means the naming of the chain will start from over here, and the location of the substituent is indicated by alpha, beta, gamma, or del. So that's the important part. அதையும் நம்ம கண்டிப்பாக ஞாபகம் வச்சுக்கணும். ஸோ அதாவது லொக்கேஷன் ஆஃப் த, as we can see, we will start our numbering from the very carboxylic acid group or the carbonyl compound group, which is going to be of the highest priority. So இங்கே பார்த்தீங்கன்னா that's the thing. Then I can still reduce it more. Yeah, I think it's fine now. Yeah. So no, 1 minute. Yeah, this is fine actually. So it's alpha position and alpha position and beta position. I'm having a bromine, that's a substituent, so it's a beta bromo butyraldehyde. So it's butyr, which means that we'll have to include the carbon present in the carboxylic or carbonyl compound in the parent chain. That's important. So inge pathina I'm including it over here, so which means I'm having 1 2 3 and 4 carbons, which means that will give me a it's going to be a butyroic acid, but I will replace the oic acid with the aldehyde, so it's going to be a beta bromo butyraldehyde. So that's the important common name nomenclature. The common names of ketones. So இப்போ நம்ம வந்து ஆல்டிஹைட்ஸ்களுடைய காமன் நேம் எப்படி பண்ண காமன் நேம் நாமன்கிளேச்சர் பார்த்தோம். இப்போ வந்து கீட்டோனுடைய நாமன்கிளேச்சர் அப்படின்னு பார்ப்போம். The common names of ketones are derived by naming two alkyl or aryl groups bonded to the carbonyl group. So the locations of the substituents are indicated by the Greek letters. So another way, so இங்கேயும் பார்த்தீங்கன்னா the location of the substituentsன்றதை வந்து we are using alpha, alpha dash, beta or beta dash, and so on, beginning with the carbon atoms next to the carbonyl carbon indicated as alpha, alpha dash. So we will start with alpha, alpha dash, which indicates the carbon atom present directly attached to the carbonyl group. So some ketones have historical common names. The simplest dimethyl ketone is acetone. So simplest dimethyl ketone அப்படின்றது acetone என்று சொல்றாங்க. Okay. Alkyl phenyl ketones are usually named by adding the name of the acyl group after the prefix. So I think this one has to be marked in yellow color, I mean this color. And then the alkyl phenyl ketones are usually named by adding the name of the acyl group as the prefix to the word phenol. So let's see the examples first. So இப்போ வந்து கீட்டோனோட காமன் நேம் வந்து எப்படி டிரைவ் பண்ணுறோன்னா, நம்ம ரெண்டு சப்ஸ்டிடியூவன்ஸ் கார்பனிக் காம்பவுண்டோட அட்டாச் இருக்க ரெண்டு அல்கைல் அல்ல அரைல் குரூப்ஸோட நேம்ஸை பேஸ் பண்ணி தான் நம்ம டிரைவ் பண்ண போகிறோம். and then the substituents we will have alpha or beta, something like that. We'll indicate them with these Greek letters. Next is some, and then we'll have certain historical names as well. And one important thing என்னதுன்னா, we'll have alkyl phenyl, அதாவது alkyl மற்றும் aryl இரண்டு குரூப்புமே will be attached to the carbonyl compound. So which means that we will have the acyl group as the prefix to the phenol. ஸோ அதாவது என்னென்னா, இப்போ இந்த பர்டிகுலர் எக்ஸாம்பிள் பார்ப்போம், அசிட்டோஃபினான் அப்படின்ட்டு இந்த பர்டிகுலர் எக்ஸாம்பிளில். ஸோ திஸ் இஸ் த கார்பன் காம்பவுண்ட். ஐ எம் ஹேவிங் 2 கார்பன் ஆட்டம் அட்டாச் டு இட், விச் மீன்ஸ் இட்ஸ் கோயிங் டு பி கீட்டோன். ஸோ இதுக்கு நான் காமன் நேம் எப்படி வைக்க போகிறேன் அப்படின்னா, ஸோ ஐ எம் ஹேவிங் அ ஃபீனால் குரூப். ஐ மீன்ஸ் ஆக்சுவலி நாட் ஃபீனால், பட் we will have phenon அப்படின்ற நேம் will be the root word, something like that. And the remaining acyl group, so here I am having aceto, so it means that it indicates 2 carbon atoms presence. So here it has 1 2 3 atoms, which means it's going to be given a propiophenol. And then here it's going to be benzene is going to be the acyl group, so it's going to be a benzophenol. So here it's the propane that's going to be phenol, and this is acetophenol. And acetone is a historical name given, so which means that we can't change it over here, or it should be a dimethyl ketone. That's all about it. So let's enter into the IUPAC naming nomenclature. The IUPAC names of the open chain aliphatic aldehydes and ketones are derived from the names of the corresponding alkanes by replacing the word E with AL and ONE. Simple. So இப்போ நம்ம என்ன பண்ண போகிறோம்னா, ஜஸ்ட்டு நம்ம ஆல்கைல் குரூப்ஸ் என்னென்னலாம் ஆட் ஆகியிருக்கோ அதிலெல்லாம் இ அப்படின்றத ரிமூவ் பண்ணிட்டு வில் ஜஸ்ட் ஆட் ஏஎல் ஃபார் ஆல்டிஹைட் ஆர் ONE ஃபார் கீட்டோன். Corresponding alkanes by replacing. So it is in case of alkanes for open chain aliphatic aldehydes. That's important part. In case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehydic group. So that's important. The aldehydes number starting from the carbon of the aldehyde group, while in the case of ketones the number begins from the end nearer to the carbonyl group. So ஒரு ஆல்டிஹைடோட கேஸில் பார்த்துக்கிட்டோம்னா நம்ம எப்போவுமே நம்பரிங் will be started from the group present in aldehyde, I mean in the carbonyl group. ஆனால் in case of ketone we will have the adjacent carbon, we will consider the adjacent carbon to be the first carbon of the parent chain. Substituents are prefixed in alphabetical order along with numerals indicating their positions in the carbon chain. அதாவது இந்த சப்ஸ்டிடியூவன்ஸ்க்கெலாம் we will give certain alphabetical order preference, அதை வச்சு தான் we will prefix them அப்படின்றத சொல்கிறாங்க, with numerals indicating their positions. So we will make use of alphabetical order for the substituents. Okay, the same applies to the cyclic ketones. So இப்போ நம்ம ஓப்பன் செயின் அலிஃபேட்டிக் கீட்டோன்ஸ் அண்ட் அலிஃபேட்டிக் ஆல்டிஹைட்ஸ்க்கு பார்த்துட்டோம். தட் இஸ் டன். ஸோ வி வில் ஜஸ்ட் மார்க் இட் அவுட் ஓவர் ஹியர். திஸ் இஸ் ஃபார் அலிஃபேட்டிக். ஓகே, அலிஃபேட்டிக் ஆல்டிஹைட்ஸ் அண்ட் கீட்டோன்ஸ். Okay, indicating their positions in the carbon chain. The same applies to cyclic ketones where the carbon is numbered 1. The aldehydic group is attached to a ring. The suffix carbaldehyde is added for the full name of the cycloalkane. Okay, so the numbering of the ring carbon starts from the carbon atom attached to the aldehydic group. The name of the simplest aromatic aldehyde carrying aldehydic group on a benzene ring is benzene carbaldehyde. However, the common name benzaldehyde is also accepted by the IUPAC nomenclature system. Other aromatic aldehydes hence named as substitute benzaldehydes. So okay, இப்போ நம்ம we are entering into cyclic part. So cyclic structuresல என்னன்னா, cyclic ketonesல we'll have the carbonyl carbon to have number 1. An aldehyde group இருக்கும் பொழுது and aldehyde group is attached to the ring, the suffix aldehyde is attached to the ring. So aldehyde as itself is attached to the ring. The suffix carbaldehyde is added after the full name of the cycloalkane. So cycloalkane போட்டுட்டு and we will add a carbaldehyde. The ring of the ring carbon atom start from the carbon atom attached to the aldehyde group. Okay, so the name of the simplest carbaldehyde is benzene carbaldehyde. Okay, fine. ஸோ இப்போ நம்ம ஓப்பன் செயின் பார்த்தோம். ஓப்பன் செயினில் என்ன சொன்னாங்கன்னா, இஃப் இட் இஸ் அன் ஆல்டிஹைட் வில் கவுண்ட் த கார்பன். ஸோ ஹியர் வி ஆர் ஹேவிங் ஹைட்ரோஜன் aryl group and a C double bond O group, which means it's a carbonyl compound group with a hydrogen and alkyl group attached to it, which means it's going to be a aldehyde. That means we will have to count these two carbons as well. So இப்போ இந்த ரெண்டு கார்பனை கவுண்ட் பண்ணோம் அப்படின்னா, then obviously it's going to be eth is going to be the number of carbon. Ethane should be written first, and then we'll replace E with EL. So that's it, that's all about it. That's all ethanaldehyde or ethanol. Next we'll start our numbering. So இங்கே வந்து கண்டிப்பாக we'll check for the longest carbon. So இங்கே it's aldehyde because there's a carbon group with a hydrogen attached to it. That means we'll have to start the numbering over here. It's 1 2 3. We can't go here 4 because we have still a longer chain, which means we'll continue over here. It's a 4 5 6 and 7. So we'll go with alphabetical order. This is bromo and this is methyl. So we'll have 4 bromo, 3 methyl, and we have heptane. We'll write it as heptane. Alkane group அப்படி எழுதுங்க, and எழுதுனதுக்கு பிறகு we'll replace with Al. So 4 bromo, 3 methyl, heptanol. That's it, that's all about it. Next we are having a cyclic structure. Cyclic structure la it is present in the ring அப்படின்னா we will have to consider that carbon as well. So இங்கே வந்துட்டு it's going to be 1 and 2 3. We can go in this way as well, but we'll have to use the lowest locant rule, which means the substituent must have the least number, location number. So it's going to be 1 2 3 4 and 5. So 3 third position it's going to be a methyl group. So in the particular same, write the substituent 3 methyl cyclopentane. We'll write it as cyclopentane first, the first place, and then we'll replace pentane, cyclopentanol. Next இங்கே இந்த particulars we are not having the aldehyde group present in the ring, which means that we will have a carbaldehyde suffix, and in the prefix we will just have the cycloalkane structure name as it is, and we will start the numbering from the adjacent carbon to the carbon in the aldehyde group. So it's going to be 1 2 3 4 5 6. So we are having 6, which means it's a cyclohexane. We will not have hexanol, because if it is hexanol, which means that it should be present in the ring like this, but that's also not possible, which means it's a cyclohexane carbaldehyde. So that's all about it. Next in here we are having a carbonyl compound with the hydrogen in the other side, which means we'll have to first write the alkyl group name and then replace with Al. So we'll start the numbering over here: 1 2 3 4 5. So we are having 5, which means it's going to have a root word of pent, and then we'll have on the second carbon we are having the double bond, which means it's a pent2-ene, and then we have an aldehyde pent2-enol, and then we have 1 phenyl propan 1 one. And then we have a C double bond O group over here, a CH2, CH3. Okay, fine. So in the particular case we are having C double bond O group and then a benzene, that is an aryl group. Apna we'll have it's a ketone. That's fine in the first place. 1 phenyl propan 1 one. Ketone adjacent group la we will start, but here they have started. No, wait a minute. So open chain structure, right? The end nearer to the carbon group. Okay, fine. Wait. Can skip it over here. So the common name benzaldehyde is also accepted by the IUPAC. Other aromatic aldehydes are hence named as substituted benzaldehydes. However, the common name benzaldehyde is also accepted by IUPAC. Other aromatic aldehydes are hence named as substituted benzaldehydes. So this is not an aldehyde, this is going to be a ketone. Okay, in this case, let's say that if the ketone has a aryl group attached to one of its ends, which means that we'll have to consider the ketonic group's carbon as well. That means that we'll have to start numbering from here 1, 2, 3, and then say it's a 1 phenyl propan 1 one. So that's it. Next, oxo pentanol. So I think aldehyde is given preference over ketone, which means that basically we are having a aldehyde group and a ketonic group present, and the aldehyde group is given priority, which means that it's going to have a suffix. அப்படின்னா இந்த substituent is going to have a prefix of oxo, because ketonuக்கு வந்து the prefix is going to be oxo if it is a substituent, and the suffix is going to be ONE if it is going to be a functional group. That's it. So here we'll have to start the numbering from the carbon of the carbonyl compound, and then at the third position I'm having the ketonic group, which means it's going to be 3 oxo, and then we'll check for the number of carbons. I'm having 5 carbon, which means a 3 oxo pentane, and then I'll replace E with the EAL pentanol. And then similarly we are having a carbonyl compound over here, and we'll start the numbering. Wait a minute. So it's a 4-nitrobenzene carbaldehyde or 4-nitrobenzaldehyde. That's also fine. And I'm having 1, 2, 3. So if I'm having tricarbaldehyde, to give identical treatment to all aldehyde group, the compound is named as shown above. So we'll see some more compounds over here. First, common and IUPAC names of some aldehydes and ketones. Aldehydes, HCHO, it's a formaldehyde, that is carbon compound with 2 hydrogens attached to it. 2 hydrogens attached to it is having a 1 carbon, and it's an aldehyde, which means it's going to be a methane, and methane with aldehyde group is a methanol. That's it. Next, we are having CH3COOH. It's going to be acetaldehyde because it has 2 carbons. 2 carbons will have a common name of acid because we are having an acetic acid derivative. That's where we are obtaining the common name for aldehydes. So அது அசிட்டால்டிஹைடுன்னு சொல்லுவோம். அசிட்டால்டிஹைடில் இப்போ we'll have to go for IUPAC naming. IUPAC namingல பார்க்கும்பொழுது it's having 2 carbons. We'll have to consider the carbon of the carbon compound, so it's going to have a ethane as the okay fine, and then we'll have aldehyde ethane, and then we'll have EL, so it's ethanol. Next, CCH3OH, it's going to be aldehyde, which means that we will just draw it once. C double bond OH on one side, CH3, so it's going to be isopropyl, iso 1, 2, 3, butyraldehyde. So that's the common name, butyraldehyde. Isobutanoic acid, that's what the common name of the acid was named to be. And then for IUPAC naming, we'll have to check for the ring. It's going to be 1, 2, 3 carbon, 3 carbon with at the second carbon we have substituents. It's a 2 methyl propan propane, and then it's an aldehyde, which means we'll replace it as propanol. So that's our, and then I'm having a cyclic structure with a CHO group over here. So I think this alpha, beta, gamma. So the gamma position we are having a methyl group for the CHO, and at the alpha position I'm having a cyclohexane. Aldehyde, thaldehyde, phthalic acid. It's actually phthalic acid. Instead of COOH, we are having CHO, which means it's we'll replace it with a phthalaldehyde. But it's actually benzene ring with the CHO group, which means we'll have a carbaldehyde prefix, and we have two CHO groups, which means it's going to be 1,2 carbaldehyde, and the remaining alkyl group present, that's going to be benzene, so it's going to be benzene 1,2 carbaldehyde. Okay. And then this is M bromo carbaldehyde, but it can be written as benzaldehyde, yeah, but it's actually written as carbaldehyde will be benzene bromo benzene carbaldehyde. That's and ketone we are having CH3 CH CH2 CH2 CH3. It's a ethyl. We'll follow the uh, methyl in propyl ketone. So it will follow the alphabetical order in this case, or naming the common name. But actually, for pentane to one, okay, fine. Diisopropyl ketone 2,4 dimethyl pentane 3-one. Okay, the cyclic structure alpha methyl cyclohexanone. We'll use alpha because for common name for Greek. 2-methyl cyclohexane. Okay, and we'll replace the E with acetyl oxide. So there's something called as methyl oxide, and then we have something called as acrolein. I think these were the things to be noted. Moving on from here, we'll enter into the structure of the carbonyl group. The carbonyl carbon atom is sp2 hybridized and forms 3 sigma bonds. ஸோ என்ன சொல்ல வராங்கன்னா கார்பன் ஆட்டம் என்பதே வந்து இட் இஸ் sp2 ஹைப்ரிடைஸ்ட் அப்படின்னு சொல்கிறாங்க, அண்ட் இட் ஃபார்ம்ஸ் 3 சிக்மா பாண்ட்ஸ் அப்படின்னு சொல்கிறாங்க. த ஃபோர்த் வேலன்ஸ் எலக்ட்ரான் ஆஃப் கார்பன் remains in its p orbital and forms a pi bond with oxygen. Okay, so there are basically 4 valence electrons in which the carbonyl carbon atom is sp2 hybridized and forms 3 sigma bonds, and the fourth valence electron of the carbon remains in its p orbital and forms a pi bond with oxygen by overlap with the p orbital of an oxygen. In addition, the oxygen atom also has two non-bonding electron pairs. The oxygen atom also has two non-bonding electron pairs. Thus, the carbon-carbon and the three atoms attached to it lie in the same plane, and the pi electron cloud is above and below this plane. The bond angles are approximately 120 degrees as expected of a trigonal planar structure. Okay, so the carbon and the three atoms attached to it lie in the same plane, and the pi electron cloud is above and below this plane. Bond angles are approximately 120 degrees as expected of a trigonal planar structure. So basically we are talking about a structure in which the carbon is sp2 hybridized, the fourth valence electron remains in the p orbital and forms a pi bond with oxygen with overlap of the p orbital of an oxygen, which has two non-bonding electron pairs. Thus, the carbon-carbon three atoms attached to it lie in the same plane, and the pi electrons cloud is above and below this plane, and the bond angles are approximately 120 degrees as expected. The carbon-oxygen double bond is polarized because we have oxygen as electronegative atom. It is relatively electronegative அப்படின்னு சொல்கிறாங்க, and hence the carbon is an electrophile. Electrophile அப்படின்னா basically it can accept a pair of electrons. If something has a tendency to accept a pair of electrons, which means that it's going to be a Lewis acid. And similarly, a carbonyl oxygen which is polarized and has a tendency to donate electrons, a pair of electrons, is called as a Lewis base. So we can have an acid base reaction as well in this carbon compounds. So they have substantial dipole moments and are polar than ethers. So there's some comparison occurring, which means that has to be noted. Are polar than ethers. The high polarity of the carbonyl group is explained on the basis of resonance, involving a neutral A and dipolar B structures as shown. So explained on the basis of resonance. Neutral A and the dipolar B structures. Okay, so we are basically discussing about the structure. It's a sp2 hybridized carbon. The fourth valence electron is being the pi bond, the p orbital. The oxygen atom also has two non-bonding electron pairs. It's a carbon-carbon. The three atoms attached to it lie in the same plane, and the pi electron cloud is above below the plane. That's fine. Preparation of aldehydes and ketones. Some important methods for the preparation of aldehydes and ketones are as follows. Oxidation of alcohols. Methods for the preparation of aldehydes and ketones. Entering into the first part is done, the nomenclature and how these guys are structurized, and based upon this we will talk about certain preparation reactions of the aldehydes and ketones. So some important methods for the preparation of aldehydes and ketones are as follows. By oxidation of alcohols. Aldehydes and ketones are generally prepared by oxidation of primary and secondary alcohols. Okay, so for this I'll have to refer for unit 7 it seems. Okay. Actually there are a lot of oxidation reactions that's present. For volatile alcohols and is of industrial application. In this method, alcohol vapors are passed over heavy metal catalysts. Primary and secondary alcohols give aldehydes and ketones respectively. So next we'll use dehydrogenation of alcohols. By dehydrogenation process, we are basically creating a double bond between the carbon and oxygen. So this method is suitable for volatile alcohols in this of industrial application. So basically it is applicable for volatile alcohols. So that's an important part. And is of industrial application. In this method, alcohol vapors are passed over heavy metal catalysts. alcohol vapors are passed over heavy metal catalysts. Okay, so here important part என்னன்னா primary and secondary alcohol give aldehydes and ketones respectively from hydrocarbons. So by hydrocarbons basically we are entering into ozonolysis. The ozonolysis of alkenes, as we know, the ozonolysis of alkenes followed by reaction with zinc dust and water gives aldehydes. Ketones are a mixture of both depending on the substitution pattern of the alkene. So யுகங்களை தேடி பதிகள் கோடி அதிசயம் அதுவாய் நிகழுமே. Okay, some methods for the preparation of aldehydes and ketones. We are first having the oxidation of alcohols. Alcohols oxidize பண்ற மூலமா we can obtain aldehyde or ketone. Primary alcohol and secondary alcohol give aldehydes and ketones. Dehydrogenation of alcohols. Dehydrogenation basically we will use only volatile alcohols. We'll basically pass them over heavy metal catalysts, and then from primary and secondary alcohols we are obtaining aldehydes and ketones respectively. And then from hydrocarbons we are having the ozonolysis of alkenes. As we know, ozonolysis of alkenes followed by reaction with zinc dust and water gives aldehydes, ketones, mixture of both depending on the substitution pattern of the alkene. So ozonolysis. So alkene ozonolysis அப்படின்றதுல reaction with zinc dust and water gives aldehydes, ketones are a mixture of both depending on the substitution pattern by the alkene. So we have to refer unit 9 of class 11 it seems. What the heck? Okay, fine. So by hydration of alkynes, so we are having certain hydration reactions. So by hydration of alkanes also I am able to obtain this addition of water to ethine in presence of sulfuric acid and HgSO4 gives acetaldehyde. Presence of sulfuric acid and HgSO4 gives acetaldehyde. All other alkanes gives ketones in this reaction. Okay, so இப்போ என்ன சொல்ல வராங்கன்னா addition of water to ethine in presence of sulfuric acid and mercury sulfate gives acetaldehyde. So it's a preparation reaction it seems. All other alkanes give ketones in this reaction, so I will have to refer class 9 for this. So for ozonolysis, that is from hydrocarbons and alkanes. Okay, and from dehydration we'll have to go for unit 7. That's fine. Now we'll enter into preparation of aldehydes from certain unknown risks. The first one is being the acyl chloride. Acyl chloride, which means that with one alkyl group and other between acyl chloride is hydrogenated over catalyst palladium on barium sulfate. This reaction is Osmond reduction. So basically we are trying to reduce, that is turning chloride hydrogen by reducing a catalyst. It's palladium. So Rosenmund reduction basically involves the reduction of an acyl chloride in presence of hydrogen. Rosenmund reduction. So that's Rosenmund reduction from nitrile and esters. Nitriles are reduced to corresponding imine with stannous chloride in presence of hydrochloric acid, which on hydrolysis gives corresponding aldehyde. So nitrile abdina basically it's a C-triple group. So basically we will reduce it to its corresponding imine. Imine is basically it's a C double bond N group. C triple bond N is a nitrile, C double bond N is a imine. In presence of stannous chloride we will basically do this reduction process. So stannous chloride is one important reducing agent we will use in organic chemistry so often. Presence of hydrochloric acid corresponding aldehyde. So we will basically hydrolyze this and then we will obtain the corresponding aldehyde. So next preparation reaction, first one from acyl chloride we did hydrogenation in presence of palladium on barium sulfate. This is reaction is what we call as the Rosenmund reduction, and then we had the Stephen reaction. This reaction is the Stephen reaction. Alternatively, nitrate isobutyl aluminum hydride diball H to imines followed to aldehydes. தவிர்த்து ஸ்டானஸ் குளோரைடை பயன்படுத்துகிற H டைபால் H அப்படின்னா என்னன்னா டை ஐசோபியூட்டில் அலுமினியம் ஹைட்ரைட் diisobutyl aluminum hydride to imines. So imine convert பண்றதுக்கு we are having two reducing agents. One is diball H and another one is the stannous chloride for converting nitriles into imines. And then we will hydrolyze them. Hydrolysis basically acid catalyzed hydrolysis, in which will okay. So we are being given certain important reactions. That is a nitrile in presence of diisobutyl aluminum hydroxide hydride. We are obtaining aldehyde, and an example is given over here. So in this particular example, we do not only the C double bond O. I mean, C triple bond N group is being affected due to this diball, and none of other unsaturated compounds are entering in this. Similarly, esters are also reduced to aldehydes with diball hydrogen. Okay, so we are having esters. So esters same one we can actually reduced. So this is one important part. Esters are also reduced to aldehydes with dibyl hydrogen. Okay, fine. Dibyl hydride. So next, from hydrocarbons preparation by oxidation of methyl benzene. Aromatic aldehydes, benzaldehyde and its derivative are prepared from aromatic hydrocarbons. So if I have to create certain aromatic aldehydes, then certainly I will have to use certain aromatic alkanes or hydrocarbons respectively. Now first of all, we'll enter into the oxidation of methyl benzene. By oxidation of benzene, strong oxidizing agents oxidize toluene. So ஒரு toluene அப்படின்றது basically it's a benzene ring with a methyl group attached to it. Strong oxidizing agents oxidize toluene and its derivatives to benzoic acid. So எந்த ஒரு strong oxidizing agent பயன்படுத்தினாலும் directly it will convert into benzoic acid. However, it is possible to stop the oxidation at the aldehyde stage with suitable reagents that convert the methyl group to an intermediate that is difficult to oxidize further. Okay, so இப்போ நம்ம என்ன பண்ண போகிறோம் அப்படின்னா, it is possible to stop the oxidation at aldehydic stage itself. எப்படின்னா we will use certain suitable. Okay, so the following methods are used for this purpose. The first one is chloride அப்படின்னா it's going to be Cr. Chromyl chloride. Chromyl a chromium complex which on hydrolysis gives the corresponding benzaldehyde. So basically நம்ம என்ன பண்ண போறோம்னா, ஜென்ரலாக ஒரு ஸ்ட்ராங் ஆக்சிடைசிங் ஏஜென்ட் பயன்படுத்தும்போது பென்சோயிக் ஆசிட் ஃபார்ம் ஆகும் ஃபார் toluene or toluene derivatives. Now we are going to stop it by using a chromyl chloride. ஸோ இங்கே பர்டிகுலர் கேஸில் இந்த chromyl chloride வந்து அந்த பர்டிகுலர் பென்சால்டிஹைட் டூனோட ரியாக்ட் பண்ணும்பொழுது இட் ஃபார்ம்ஸ் the methyl group and forms a chromium complex. So as we can see, chromyl chloride in presence of a non-polar solvent. So non-polar solvent CS2 is a non-polar solvent. Okay. So I am obtaining a complex. So it's a chromium complex. So in the chromium complex அப்படின்றத basically we'll just write it down so that we'll remember it. Maybe it might be useful after some time. So this is toluene plus chromyl chloride. You just write it as chromyl chloride in presence of CS2, chromyl chloride. யுவதிகள் தேடி அவதிகள் கோடி OCr OH Cl2 taken twice. So I'm basically oxidizing the carbon. எப்படி பண்ணுறோன்னா, already there are 3 hydrogens and then I'm adding chromium, that's one part, and then I'm adding 2 oxygens. So so next upon hydrogen we are obtaining benzaldehyde. It's ETOD reaction அப்படின்னு சொல்லுவோம். So basically the conversion of aromatic alkane to hydrocarbon to benzaldehyde by oxidizing them in presence of certain mild oxidizing agents such as usage of chromium chloride by creating a complex will obtain benzaldehyde. So use of chromic acid. So அதே மாதிரி similarly we'll have something called as chromic toluene or substitute to toluene is converted to benzalidine diacetate. on treating with chromic oxide in acetic anhydride. The benzylidene diacetate can be hydrolyzed to corresponding benzaldehyde with aqueous acid. So basically, we are creating something called as, so initially in chromyl chloride we created something called as chromium complex, and here we are creating something called as benzylidene 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 diacetate, which means it has two acetate groups. Acetate is OC bond OCH3. How I'm obtaining this? Basically, I'm having certain toluene derivative upon reaction with chromic acid, chromic oxide of acetic anhydride. Basically, it is a derivative of carboxylic acid where we'll remove water, that's acetic anhydride. So it's a type of a solvent. Chromic acid, acetic anhydride in presence of certain at normal room temperatures. No, I think it's 273, which means 0 to 10 kelvins. In the particular state lab, we are creating something called as a benzylidene. So benzylidene diacetate on treating chromic oxide in acetic anhydride. The benzylidene diacetate can be hydrolyzed to corresponding benzaldehyde. So benzylidene diacetate, I am creating it. I am just hydrolyzing in presence of heat. I am obtaining a benzaldehyde. So that's one reaction, and then we have something called as by side chain chlorination followed by hydrolysis. Just by side chain chlorination. So basically, for aromatic aldehydes, if I'm having certain, for creating aromatic aldehydes, if I'm having a side chain alkane group, that's well and good. By free radical halogenation, I can basically obtain a chlorine to be to the side chain, and by hydrolyzing it, I'm basically obtaining the effective benzaldehyde. ஸோ அதுதான் வந்து சைடு செயின் குளோரினேஷன். ஓகே, ஸோ இதை வந்து பென்சால் குளோரைட் அப்படின்னு சொல்லுவாங்க. ஃபர்ஸ்ட்டு ஃபார்ம் ஆகிற அந்த பர்டிகுலர் காம்ப்ளெக்ஸில் அந்த காம்பவுண்ட் பேர் ஹைட்ரோலஜி. திஸ் இஸ் அ கமர்ஷியல் மெத்தட் ஆஃப் ப்ரிப்பரேஷன் ஆஃப் பென்சாலேட். ஸோ கமர்ஷியல் மெத்தட்னு சொல்லுவாங்க. திஸ் லுக்ஸ் ரிலேட்டிவ்லி சிம்பிளர் இல்லையா? Commercial methodology usage. Next we have something called as Gatterman-Koch reaction. Gatterman-Koch reaction அப்படின்றது it's going to be an important organic chemistry reaction. Okay, யுவதிகள் தேடி அவதிகள் கோடி அதிசயம் அதுவாய் நிகழுமே. When benzene or its derivatives is treated with carbon monoxide and hydrogen chloride in presence of anhydrous aluminum chloride or cuprous chloride, it gives benzaldehyde or substituted benzaldehyde. This reaction is known as the Gatterman-Koch reaction. So Gatterman-Koch reaction அப்படின்னா என்னன்னா, we have a benzene, so ஒரு டெரிவேட்டிவ் இல்லை வெறும் நார்மல் benzene, and treating with carbon monoxide and hydrogen chloride in the presence of anhydrous aluminum chloride or cuprous chloride. Anhydrous aluminum chloride or cuprous chloride are basically using carbon monoxide and HCl in presence of anhydrous aluminum chloride, cuprous chloride, and gives and benzaldehyde. This is called a Gatterman-Koch reaction. And then we have preparation of ketones from acyl chloride. From acyl chlorides, treatment of acyl chlorides with dialkyl cadmium prepared by the reaction of cadmium chloride with Grignard reagent gives ketones. ஸோ இப்போ அசைல் குளோரைட்லேருந்து எப்படி கீட்டோன் கிரியேட் பண்ண போகிறோம் அப்படின்றப்போ, இட்ஸ் பேசிக்கலி RC double bond OCl டைப் ஆஃப் காம்பவுண்ட். ட்ரீட்மெண்ட் ஆஃப் அசைல் குளோரைட் வித் dialkyl cadmium. ஸோ let's see what is dialkyl cadmium. Basically cadmium bonded with two chlorine, bromine or iodine or fluorine, whatever it is. I'm obtaining prepared by the reaction of cadmium chloride. Cadmium chloride with Grignard reagent. Okay. Aldehyde benzoyl rosin reduction. For ketones, we are using some other thing. That's we are using dialkyl cadmium. How we are obtaining it? By reaction with Grignard reagent. After reaction, I am obtaining dialkyl cadmium and 2 mgx Cl. Okay, so it's 2R dash C double bond O Cl plus R2CD, which gives rise to 2R dash C double bond O R plus cadmium chloride. Okay, fine. Okay, fine. I think it's 1 hour. Not yet. Okay, we'll just finish this off and then we'll have for physical properties will continue after some time. So from nitriles, so for nitriles, how we are obtaining? Treating a nitrile with Grignard reagent followed by hydrolysis yields. ஸோ இப்போ ஒரு கிரிக்னாட் ரிஏஜென்ட்டோட நைட்ரைல வந்து ரியாக்ட் பண்ண வைக்கும் பொழுது இப்போ சி டபுள் பாண்ட் சி ட்ரிபிள் பாண்ட் எண்ணில் ஒரு பாண்ட் இஸ் broken and it was the R minus group is attached. Basically one of the bonds is broken with the nitrogen and the nitrogen is gaining a negative charge. This negative charge with the MgBr having a positive charge, both are bonded together. Upon hydrolysis of this NMGBr, I'm obtaining a C double bond O group instead of a C double bond N group. So basically இங்கே நம்ம ஞாபகம் வச்சுக்க வேண்டியது என்னன்னா, ஒரு நைட்ரைல் குரூப்போட ஒரு கிரிக்னாட் ரியேஜென்ட் வந்து ரியாக்ட் பண்ணுது அப்படின்னா, ஸோ நைட்ரைல் குரூப்போட கிரிக்னாட் ரியேஜென்ட் ரியாக்ட் பண்ணுதுன்ற பொழுது இன் ப்ரெசன்ஸ் ஆஃப் ஈத்தர், it's basically doing something like a nucleophilic attack on this carbon, and this guy is obtaining a negative charge as a whole and this guy is having a positive charge as a whole, and the MgBr and MgBr upon hydrolysis C double bond O C6H5, and from benzene or substituted benzene or substituted benzene, when benzene or substituted benzene is treated with acid chloride. So I am having certain derivative of benzene, and when it is reacted with an acid chloride or an acyl chloride and acid chloride both are same, the presence of anhydrous aluminum chloride, it affords the corresponding ketone. So usage of acyl chloride is going to be one important part, and it's going to be a Friedel-Crafts acylation reaction where we'll have RC double bond OCl in presence of anhydrous ClCl3. Yep, this reaction is known as a Friedel-Crafts acylation reaction. Okay, so that's all about it. So that's the preparation reactions, and then we'll enter into the physical properties now. Before that, we'll have certain examples and in-text questions to be answered. So give names of the reagents to bring about the following transformation. Hexane 1-ol, an alcohol to aldehyde. Alcohol to an aldehyde, basically it's a open chain alcohol. Open chain alcohol can be converted to aldehyde by two reactions. One by dehydrogenation if it is a volatile alcohol, or we can use oxidation, mild oxidizing agents. So I think here they are using PCC, beryllium chromium, something like that. So they are using PCC, which is a mild oxidizing agent which converts alcohol, a primary alcohol, to a aldehyde. So that's the reaction. Second one is the cyclohexanol to cyclohexanol. Cyclohexane, and I'm having an alcohol that's a OH group attached to a cyclohexane, and I'm have to convert it into cyclohexanone. Okay, they are using anhydrous CrO3. So chromic acid. So whenever I'm having அதாவது எப்போதெல்லாம் ஒரு அரோமேட்டிக்கு அல்லது சைக்ளிக் ஸ்ட்ரக்சர் வந்து இன்வால்வ் ஆகப்படுகிறதோ, ஒரு குரோமிக் ஆசிட் அண்ட் அன்ஹைட்ரஸ் குரோமிக் ஆசிட் இல்லை CrO3 பயன்படுத்தும் பொழுது ஐ எம் அப்டைனிங் திஸ் ரியாக்ஷன். ஓகே, நெக்ஸ்ட்டு வந்து பேராஃப்ளூரோடொலுவின். ஸோ டொலுவின் டெரிவேட்டிவ்னு வந்துட்டாலே அதை ஆல்டிஹைடாக கன்வெர்ட் பண்ணணும்னா கண்டிப்பாக குரோமைல் குளோரைடு பயன்படுத்த வேண்டியதாக இருக்கும், இல்லைனா குரோமிக் ஆசிட் அப்புறம் குரோமிக் ஆக்சைடு இன் பிரசன்ஸ் ஆஃப் அசிட்டிக் அன்ஹைட்ரைட் பயன்படுத்த வேண்டியதாக இருக்கும், அல்லது குரோமைல் குளோரைடும் பயன்படுத்தலாம். அண்ட் தென் அதுக்கப்புறமாக we can use hydrolysis as well. நெக்ஸ்ட்டு ஈத்தைன் நைட்ரைல் டு இத்தனால். ஸோ நைட்ரைல் பார்ட்டை வந்து இத்தனாலாக கன்வெர்ட் பண்ணோம்னா I think we can use ethanol aldehyde. Diball H. Okay. டைபால் டைபால் அச்சும் பயன்படுத்தலாம் அல்லது we can use another reducing agent, that is essential to stannous chloride in presence of HCl can also bring about this reaction, or we can use diisobutyl aluminum hydride diball H as well. And then we have ether nitrile to ethanaldehyde, and then we have allyl alcohol to propanol, allyl alcohol to propene. So basically we'll have to convert an alcohol to an aldehyde, which means we'll have to use a mild oxidizing agent, and for this purpose we can use PCC. And then we have but2ene to ethanaldehyde. but2ene from alkenesல இருந்து carbonyl compounds form பண்றதுனாலே we have only ozonolysis, and ozonolysis we will use reductive ozonolysis for the formation of an aldehyde over here, but2ene. Yeah, I think that's fine. Write the structures and product of the following reactions. So basically this is acylation reaction. Acylation na we will remove the Cl and directly add it to the carbon. So I will have to draw the structures, that's it, right? Yeah. And then I have dialkyl cadmium with CH3C double bond to Cl, which means it's going to form a R2 double bond O, RR dash C double bond O. I think that's the reaction. Once R dash C double bond O R in. Yeah. From alkyne if I'm using HgSO4 H2SO4, I'm obtaining an alketone, I think. In chromic chloride and hydrolysis for toluene derivative knowledge, it's going to give me a aldehyde. Aldehyde is going to be CHO. So it's a carbaldehyde, benzene, 4 nitrobenzene carbaldehyde, 4 nitrobenzaldehyde. அப்படின்னு சொல்லலாம். Only this alkyne part I'm unaware of it. And then from here on we will continue for some time later. Before that, physical properties physical properties of aldehydes and ketones. Okay, let's just wait for some time. Let's have a break. Entering into the physical properties of aldehydes, ketones, the carbonyl compounds. The physical properties of aldehydes and ketones are described as follows. Methanol is a gas at room temperature. அதாவது மீத்தேன் ஆல், அதாவது CHCHOO அதெல்லாம் வந்து ஒரு ரூம் டெம்பரேச்சரில் கேஸாக இருக்கும். இத்தனால் என்பது இட்ஸ் அ வாலடைல் லிக்விட். அதர் aldehydes and ketones are liquid or solid at room temperature. ஸோ நமக்கு மெயினாக கொடுக்கப்பட்டிருக்க ரெண்டு ஆட்ரிபியூட்ஸ் வந்து மீத்தனால், தட் இஸ் கேஸ். Methanol is a gas, ethanol is a volatile liquid. Other aldehydes and ketones are liquid or liquid solid at room temperature. The boiling points of aldehydes and ketones are higher than the hydrocarbons and ethers of comparable molecular masses. It is due to the weak molecular association in aldehydes and ketones arising out of the dipole-dipole interactions. ஸோ அதாவது என்ன சொல்ல வராங்க அப்படின்னா, பாய்லிங் பாயிண்ட், ஒரு லிக்விட்லேருந்து கேஸாக மாறுற அந்த சமயம் அப்படின்றது வந்து it will have a higher value for aldehydes and ketones compared to the molecular hydrocarbons and ethers of comparable molecular masses due to the weak molecular association in aldehydes and ketones arising out of the dipole-dipole interactions. Also, their boiling points are lower than those of alcohols of similar molecular masses due to absence of intermolecular hydrogen bonding. Okay. The following compounds of molecular masses 58 and 60 are ranked in order of increasing boiling points. Okay, so இப்போ அதாவது என்ன சொல்ல வராங்க அப்படின்னா, the boiling points are lower than those of alcohols of similar molecular masses due to the absence of intermolecular hydrogen bonding. Okay, it is also lower than the alcohols of similar molecular masses due to the absence of hydrogen bonding. The following compounds of molecular masses 50 and 60 are ranked. So basically we are having a hydrocarbon. We're having a hydrocarbon, methoxyethane, it's a ether. I'm having a aldehyde, a ketone, and a alcohol. So what that we are being given is that for boiling point, an alcohol will have a greater boiling point than that of aldehyde. So let's write it as let's write it as double bond O compounds. So it is due to the fact that there is an absence of intermolecular hydrogen bonding. And then we have the hydrocarbons and ethers, so that's fine actually. Next, the lower members of the aldehydes and ketones such as methanol, ethanol, propanone are miscible with water in all proportions because they are able to form hydrogen bond with water. So இங்கே என்ன சொல்ல வராங்க அப்படின்னா, ஒரு aldehyde அல்ல ஒரு ketone like methanol. Let's just write it directly. Methanol, ethanol and propanone miscible with water in all proportions because they form hydrogen bond with water அப்படின்னு சொல்கிறாங்க. Fine. So இப்போ இதெல்லாம் வந்து it forms a hydrogen bonding with water அப்படின்ற சொல்கிறாங்க. However, the solubility of aldehydes and ketones decreases rapidly on increasing the length of the alkyl chain. அதாவது என்ன சொல்ல வராங்கன்னா, the solubility of aldehydes and ketones decreases on increasing the length of alkyl chain because it is due to the fact that the hydrophobic part will be longer. All aldehydes and ketones are fairly soluble in organic solvents. The lower aldehydes have sharp pungent odors. As size of the molecule increases, the odor becomes less pungent and more fragrant. In fact, many naturally occurring aldehydes and ketones are used in blending of perfumes and flavoring agents. So the aldehydes and ketones ஓட முக்கியமான பார்ட்டே வந்து இந்த ஃப்ரேக்ரன்ஸ் அப்படின்றது தான். ஒரு லோவர் ஆல்டிஹைடுக்கு வந்து ஷார்ப் பஞ்சன்ட் ஆர்டர் இருக்கும். அண்ட் ஆஸ் மாலிகுலர் மாஸ் இன்க்ரீசஸ் த ஆர்டர் பிகம்ஸ் லெஸ் பஞ்சன்ட். அண்ட் மோஸ்ட் ஆஃப் த ஆல்டிஹைட்ஸ் அண்ட் கீட்டோன்ஸ் அனைத்துமே வந்து லைக் இட் இஸ் ஃபேர்லி சாலிபிள் இன் ஆர்கானிக் சால்வன்ஸ். ஆர்கானிக் சால்வன்ஸ்னால் பேசிக்கலி இட்ஸ் லைக் பென்சீன், ஈத்தர், மித்தானால் இந்த மாதிரியான சில லிக்விட் சால்வன்ஸ்லாம் அதே இட் வில் பி ஃபேர்லி சாலிபிள். ஸோ இதுதான் வந்து ஃபிசிக்கல் ப்ராப்பர்ட்டிஸ் போல். Arrange the following compounds in the increasing order of the boiling points. So we are having aldehyde. We are having aldehyde, I'm having alcohol, I'm having a ether, and I'm having a alkane. So this guy has 1 2 3 4 4 carbons, 1 2 3 4 4 carbons, 4 carbons and 4 carbons, which means that we knew uh, the molecular masses of these compounds are in the range of 72 to 74, since only butane 1 whole molecules are associated due to extensive. Therefore, the boiling point of butane will be the highest. Butanol is more polar than ethoxyethane, therefore, the intermolecular dipole-dipole attraction is stronger. N-pentane molecules have only weak van der Waals forces in the increasing order. அதாவது டைபோல் டைபோல் இன்ட்ராக்ஷன் காரணமாக ஒரு ஆல்டிஹைட் அப்படின்றது வந்து இட் வில் ஹாவ் அ ஹையர் பாயிலிங் பாயிண்ட் கம்பேர்ட் டு தட் ஆஃப் ஈத்தர் சொல்ல வராங்க. ஸோ அதான் பேசிக்கலி. நெக்ஸ்ட்டு அரேஞ்ச் த ஃபாலோயிங் காம்பவுண்ட்ஸ் இன் இன்க்ரீசிங் ஆர்டர் த பாயிலிங் பாயிண்ட்ஸ். So yeah, I'm not ready for this. Let's move on. Now we are entering into the chemical properties. So that's the important part of this chapter. So since aldehydes and ketone both possesses the carbonyl function group, they undergo similar chemical reactions. Rendume will have similar chemical reactions. The products will be similar, and that's how we'll go. First, nucleophilic addition reactions. Contrary to electrophilic addition observed in alkenes, the aldehydes and ketones undergo nucleophilic addition reactions. ஸோ அதாவது நம்ம அல்கீன்ஸில் பார்த்த மாதிரி எலக்ட்ரோஃபிலிக் அடிஷன் இல்லாது இங்கே நியூக்ளியோஃபைல் அட்டாக் நடக்கும் அப்படின்றத சொல்கிறாங்க. அதாவது ஏன் அப்படின்னா இப்போ பேசிக்கலி அல்கீன்ஸில் வந்து தேர் வில் பி அ பை பாண்ட் cloud which means it's something like electron rich center. So obviously electrophile attacking over there, fine, that's great. The mechanism of nucleophilic addition reaction attacks the electrophilic carbon atom. Electrophilic carbon atom is having a partial positive charge, which means it needs some amount of negative charge to be supplied for making it neutral. So nucleophile attacks the electrophilic carbon atom of the polar carbonyl group from a direction approximately perpendicular to the plane of sp2 hybridized orbitals. ஸோ அதாவது என்ன நடக்குது அப்படின்னா ஜஸ்ட் பெர்பெண்டிகுலர் டு த sp2 hybridized orbital வந்து there will be an attack அப்படின்ற சொல்கிறாங்க. The hybridization of carbon changes from sp2 to sp3 this process tetrahedral alkoxide intermediate. So the intermediate that we are obtaining in this particular process is the tetrahedral alkoxide intermediate. This intermediate captures a proton from the reaction medium to give the electrically neutral product. The net result is addition of nucleophile and hydrogen H plus across the carbon oxygen double bond as shown. Okay, so we are having certain mechanism of nucleophilic attack. So first is that there is a polar bond between carbon and oxygen, which means that carbon is becoming nucleoelectrophilic. So hence it is having a nucleophilic attack that is perpendicular, just nearly perpendicular to the. Okay, fine. Okay, the net result is the addition of nucleophile. Carbon oxygen double bond. Okay, so reactivity. When reactivity நடக்குன்ற பார்ப்போம். Aldehydes are generally more reactive than ketones in nucleophilic addition reaction due to the fact that there is steric hindrance in ketones. So we will say that the reactivity of aldehyde due to steric hindrance. Sterically, the presence of two relatively large substituents in ketones hinders the approach of nucleophile to the carbonyl carbon than in aldehydes, having only one such substituent. Electronically, the aldehydes are more reactive than ketones because two alkyl groups reduce the electrophilicity, and that's one factor. Next, the alkyl groups reduces the electrophilicity. So that's another part to be noted. Electronically, aldehydes are more reactive. So this is the reactivity part, and the nucleophile mechanism என்னன்றதை பார்த்தோம். sp2 to sp3 conversion நடக்கிறது. That's a stool. Okay, fine. Would you expect a benzaldehyde to give more reactive, less reactive nucleophilic addition reactions than propanol? So basically they are asking about propanol. CH3, CH2, C double bond OH. This is propanol. And this guy has an alkyl group and a hydrogen group, and the electrophilicity is this, and we are comparing it with benzaldehyde. So basically benzaldehyde will be more reactive. Benzaldehyde is less electrophilic than carbonyl of the carbonyl. Why? The polarity of the carbonyl group is reduced in benzaldehyde due to resonance. Okay, wait a minute. Why is it less reactive? Because they are talking about resonance, that is the oxygen, the double bond. So basically this transfers away from that. So resonance காரணமாக ஸோ கண்டிப்பாக வந்து ரியாக்டிவிட்டி குறையும் அப்படின்றத சொல்கிறாங்க. ஸோ நெக்ஸ்ட் இதை தவிர்த்து கெமிக்கல் ரியாக்ஷன்ஸ், ஃபஸ்ட் நியூக்ளியோஃபிலிக் அடிஷன் ரியாக்ஷன்ஸ் பற்றி பேசிட்டு இருக்கோம். ஸோ இந்த கேஸில் ஜஸ்ட் அடிஷன், இட்ஸ் நாட் ரிமூவல். Some important examples of nucleophilic addition and nucleophilic addition elimination reactions. Addition of hydrogen cyanide addition அப்படின்ற எப்படி பார்ப்போம். Aldehydes and ketones react with hydrogen cyanide to yield cyanohydrins. Cyanohydrin now basically it's a carbon with a hydroxyl group and a nitrile group. Cyanohydrin is carbon with a hydroxyl group and a cyanide group. Imine na C double bond N, it's nitrile na C triple bond N. This is nitrile isocyanide ஒன்று இருக்குது, அண்ட் cyanohydrin. Hydrin means it's basically OH group presence. ஸோ இப்போ இங்கே என்ன பண்ண போகிறோம்னா, ஸோ the yield is going to be cyanohydrins. This reaction occurs very slowly with pure HCN. Okay, it's going to be a very slow reaction, and அதையும் சொல்லியிருக்காங்க. Therefore it is catalyzed by a base, and the generated cyanide ion Cn- being a stronger nucleophile readily adds to the carbonyl carbon. So basically what we are obtaining is that we are using a base so that it deprotonates the H plus, and then I'm obtaining cyanide, which is going to be a nucleophile over here. Then this nucleophile is going to add readily to the carbonyl compound to yield the corresponding cyanohydrin. Cyanohydrins are useful synthetic intermediates. Useful synthetic intermediates. Okay. Addition of sodium hydrogen sulfate. Sodium hydrogen sulfate adds to aldehydes and ketones to form addition products. Position of the equilibrium lies largely to the right hand side for the most aldehydes and to the left for the most ketones due to steric equilibrium. So the sodium hydrogen sulfate அப்படின்றது basically SO3H அப்படின்றது sodium hydrogen sulfate நினைக்கிறேன். So what's going to happen is the sodium hydrogen sulfate adds to aldehydes to form addition products. So இது வந்து it's going to be addition reaction. So basically it's just going to add. and then the equilibrium lies largely to the right hand side for most aldehydes and to the left for most ketones to the steric enzymes. Obviously, steric regions in carbonyl ketones will have lesser reactivity. The hydrogen sulfide addition compound is water soluble and can be converted back to the original carbonyl compound by treating it with dilute melt. ஸோ இப்போ இங்கே இருக்கிற முக்கியமான கேரக்டரிஸ்டிக் என்னென்னா ஹைட்ரோஜன் சல்ஃபைட் அடிஷன் என்பது இட் இஸ் வாட்டர் soluble converted back to the original carbon compound by treating it with dilute mineral acid. So அதாவது see let's say I have a carbonyl compound with sodium hydrogen sulfate. Upon reaction will basically give OSO2 ONA. Upon doing a proton transfer to so to oh can we convert it back to the so mineral acid will alkali useful for separation and purification of aldehydes. Okay, fine. ஒரே ஒரு முக்கியமான பாயிண்ட் என்னன்னா when we have addition of alcohol, suppose alcohols அப்படின்றது it's going to be 1 equivalent monohydrate alcohol in the presence of dihydrogen chloride to yield a alkoxy alcohol intermediate known as hemiacetal, which further react with one more molecule of alcohol to give a geminal dial. Aldehydes react with one equivalent of monohydrate alcohol in the presence of dry hydrogen chloride to yield alkoxy alcohol intermediate known as the hemiacetals, which further react with one more molecule of alcohol to give a geminal dialkoxy compound known as shown in the reaction. So it's going to be addition reaction going to give alkoxy alcohol intermediate known as hemiacetal that reacts further to one more molecule which gives geminal dialkoxy. Alkoxy means it's a OR dash compound known as the acetal. So that's how the reaction is going to be. It's going to occur in presence of acidic medium. So the ketones react with the ethylene glycol. Let's talk about ketones. So in the ketone case it's going to react with ethylene glycol, ethylene glycol under similar conditions to form cyclic products known as ethylene glycol ketols. So it's basically going to form something called as glycol ketol in which the C double bond O group is bonded with the H2CH2OH, and this particular reaction yields the formation of CH Trihydrogen chloride protonates the oxygen of the carbonyl molecules and therefore increases the electrophilicity of the carbonyl carbon. So இப்போ நம்ம ஏன் dry hydrogen chloride, so reason for usage of using dry hydrogen chloride அப்படின்றது ஏன் பார்ப்போம். So first and foremost reason is that it protonates the oxygen of the carbonyl compound and therefore it increases the electrophilicity of the carbonyl carbon. Let's just mark it out. Protonates the oxygen of the carbonyl compounds and therefore increases the electrophilicity of the carbonyl carbon. Fine. The nucleophilic attack of the ethylene glycol will also be facility, and then acetals and ketols are hydrolyzed with aqueous amino acid to yield corresponding aldehydes and ketones respectively. So finally, upon producing these acetals and ketols, we'll just hydrolyze them and we'll obtain the form aldehydes and ketones. ஸோ என்ன சொல்ல வராங்க, அசிட்டால்ஸ் அப்படின்றதுலேருந்து we are obtaining aldehydes. Ketones, nucleophiles such as ammonia and its derivatives. Reaction is reversible and catalyzed by acid. The equilibrium phase the product formation due to dehydration of the intermediate to form. So basically it's going to be another addition reaction in which the NH2 molecule just adds up over this guy, and then it leads to the formation of basically disintegrates to Z minus and H plus. That's the reaction, and Z minus is going to be the nucleophile that's going to attack, and then further we'll obtain the formation of so this guy breaks and forms a negative charge, and there's a partial positive charge and partial negative charge formed over here. The reaction is reversible and catalyzed by acid. So it's a reversible reaction and catalyzed by acid, and the product formation is due to the rapid dehydration of the intermediate. There's a rapid dehydration occurring, which means that the OH bond is broken, and then I'm obtaining finally the C double bond N, and that's the addition of ammonia and its derivative. So we have reduction of, first we saw the reaction of addition, that's the nucleophilic addition, it's not giving an alcoholic addition. Now we are entering into the reduction process. Reduction to alcohols. So first we will see what the reduction implies. So aldehydes and ketones are reduced to primary and secondary alcohols by using the sodium borohydrate or lithium hydrate. So basically I'm using aldehydes and ketones reduced to primary and secondary alcohol if I'm using sodium borohydrate or lithium aluminum hydrate. So that's what they're trying to say. Next we have reduction to hydrocarbons. So the carbonyl group of aldehydes and ketones is reduced to CH2 group on treatment with zinc amalgam and concentrated hydrochloric acid. So basically the carbonyl groups on treatment with on treatment with zinc amalgam and concentrated hydrochloric acid, I am obtaining Clemenson's reduction. Clemenson's reduction implies that this is Clemenson's reduction, or with hydrazine followed by heating with sodium or potassium hydroxide in high boiling solvents such as ethylene glycol. That's Wolff-Kishner reduction. Wolff-Kishner reduction. Aldehydes differ from ketones in their oxidation reactions. Aldehydes are easily oxidized to carboxylic acids and treatment with common oxidizing agents like nitric acid, potassium permanganate, potassium dichromate. Even mild oxidizing like tolerance agent, Felling's reagent also oxidizes aldehydes. Ketones generally that are strong oxidizing agents. ஸோ பேசிக்கலி என்ன சொல்ல வராங்க அப்படின்னா, இப்போ நம்ம வந்து ஆக்சிடேஷன் அப்படின்ற டைப் ஆஃப் ரியாக்ஷன் பார்த்தோம்னா ஆல்டிஹைட்ஸ் அண்ட் கீட்டான்ஸ்க்கு ஒரு மாறுபாடு இருக்குது. அடிஷன் ரியாக்ஷன்ஸ் எல்லாமே சேம் தான், அண்ட் ரிடக்ஷன் ரியாக்ஷன்ஸும் நியர்லி த சேம். ஆனால் ஆக்சிடேஷன் டைப் ஆஃப் ரியாக்ஷன்ஸ் பார்க்கும் பொழுது ஆல்டிஹைட்ஸ் ஆக்சிடேட் it's going to be a relatively easier task, even by using certain strong oxidizing agents such as nitric acid, chromic acid, or dichromate or potassium permanganate. Even mild oxidizing agents, it mainly tolerance reagent and Felling's reagent also oxidizes aldehydes. So basically that's what they're trying to say. So even mild oxidizing agents like tolerance and Felling's reagents can oxidize aldehydes. Ketones are generally oxidized under vigorous conditions, that is, the strong oxidizing agents and at elevated temperatures. Their oxidation involves carbon-carbon bond cleavage to mixture of carboxylic acids having lesser number of carbon atoms than the parent ketone. So, அதாவது என்ன சொல்ல வராங்கன்னா, generally ketones are generally oxidized under vigorous conditions. Hydro number of carbon atoms than the parent two அப்படின்னு சொல்றாங்க. Fine. The mild oxidizing agents given below are used to distinguish aldehydes from ketones. So basically ketone carbon bond cleavage மூலமா carboxylic acids which are having lesser number of carbons than the carbon present in the parent ketone அப்படின்றத சொல்றாங்க. இப்போ there are certain mild oxidizing agents through which the difference between certain guys, that is the mild oxidizing agents given below are used to distinguish aldehydes and ketones. First we will use Tollens reagent அப்படின்னா, and warming an aldehyde with a freshly prepared ammonical silver nitrate solution, a bright silver mirror is produced due to the formation of a silver metal. The aldehydes are oxidized to the corresponding carboxylate anion and the reaction occurs in an alkaline medium. So basically Tollens test அப்படின்றது என்னன்னா, we will use ammonical silver nitrate solution. ஸோ அம்மோனிக்கல் சில்வர் நைட்ரேட் சொல்யூஷன்ற பார்த்துக்கோங்க, அதுதான் வந்து Tollens reagent. இந்த பர்டிகுலர் ரியாக்ஷனில் if I am having an aldehyde, so RCHO is the aldehyde, ammonical silver nitrate solution in presence of a basic medium, so alkaline medium. So that's an important point. Alkaline medium is an important point. So alkaline mediumல ammonical silver nitrate solution aldehydeோட ரியாக்ஷன் பண்ணும் பொழுது we are obtaining the formation of silver metal. Formation RCOO minus, so that's the okay, and then I'm obtaining silver formation, and then yeah, that's it, that's all about it. Next I'm having a Felling's solution. Felling's test அப்படின்னா என்ன பார்ப்போம். Felling reagent comprises of two solutions, Felling solution A, Felling solution B. Felling solution A is aqueous copper sulfate. Felling solution B is alkaline sodium potassium nitrate, that is what we call as the Rochelle salt. So இப்போ Felling test பண்ணும்போதே we are having two different salts, one வந்து A and the other one is B. The Felling solution A is aqueous copper sulfate ன்னு சொல்றாங்க. So we are having aqueous copper sulfate is the first solution, and the second one the Felling solution B, that's having sodium potassium tartarate, it's the Rochelle salt. On heating an aldehyde with Felling's reagent, a reddish brown precipitate is obtained. So the reddish brown precipitate வேற இன்னும் இல்லை, that's the cupric oxide. ஸோ இந்த குப்ரிக் ஆக்சைடு கை இருக்கார் பாருங்க, அவர் தான் வந்து lead to the formation of reddish brown precipitate. When these guys are mixed in equal proportion and heating it with an aldehyde, I'm obtaining a reddish brown precipitate. The aldehydes are basically oxidized to the corresponding carboxylate anion. And இதில் முக்கியமான விஷயம், aromatic halides do not respond to this test. Copper sulfate, which is aqueous in nature, which means it will be ionized in the first solution. The second solution, I'm having sodium potassium tartarate, that's the Rochelle salt. So upon addition of these two, on reaction with these two, I'm obtaining carboxylate anion and cupric oxide reddish brown precipitate and the water. So on heating an aldehyde with the Fillings reagent, a reddish brown precipitate is obtained. The aldehydes are oxidized corresponding carboxylate anion, and the aromatic aldehydes do not respond to mirror. And I'm obtaining carboxylate anion and a filling solution, that's Stolons, and that other one is a filling. Next, this is one type of an oxidation reaction. ஒரு டைப் வந்து என்னன்னா மித்தைல் கீட்டோன்ஸ் பை ஹாலோஃபார்ம் ரியாக்ஷன். ஸோ அந்த ஹாலோஃபார்ம் ரியாக்ஷன்ஸ்னால் என்னன்றதை பார்ப்போம். Oxidation of methyl ketones, especially methyl ketones. அதாவது one side of the ketone will be a methyl group and the other one will be certain other alkyl group அப்படின்ட்டு சொல்லியிருக்காங்க. Let's see what it is in the first place. Aldehydes and ketones having at least one methyl group linked to the carbonyl carbon atom. அதாவது at least one methyl group linked to the carbonyl carbon atom are oxidized by sodium hypohalite. எனக்கு புரியல. Aldehydes and ketones having at least one methyl group linked to the compound atom is methyl and are oxidized by sodium hypohalite. Hypohalite means NaOX என்றதான் hypohalite நினைக்கிறேன். To sodium salts of corresponding carboxylic acids having one carbon atom less than the carbonyl compound. So basically this methyl group is removed and the hypohalites halogen part will be added to this methyl group. This oxidation does not affect a carbon-carbon double bond if present in the molecule. So it basically just removes the CH3 group. Iodoform reaction with sodium hypoiodide is also used for the detection of CH3 double bond group or CH3CHOH group, which produces CH3 double bond group on oxidation. So in the particular oxidation only, it's haloform reaction. Haloform reaction sodium hypo